Great. So this is a project which tries to give an example of polymorphism in C++. Okay, so there are two examples in this. One is an example of class shape, right? And so shape is the base class, right? And we have two other classes. So here we have a rectangle class which is derived from shape. Okay, so this particular function area in the base class, it is marked as virtual, so which means at runtime, depending on the type of object that is created, so it depends whether shape is created or rectangle is created. So if a rectangle is created, then the area function defined within the rectangle class will be executed. So that's what this keyword is for, to decide at runtime whether to call the base class area function or to call the derived class area function. And in the same way we have a triangle class over here. So if you see the main function, we are creating pointer variable of type shape, right? So we have not created the shape object as yet. It's just a pointer, so it can point to any other object of the same type. So here we have the actual object, rectangle and triangle, and we are testing the polymorphism. So when you say rec.setWidth, so actually setWidth is implemented in the base class. So in the same way, when you call a setWidth on the triangle object, the setWidth function is actually implemented in the base class. So you see, this is a rectangle class, there is no setWidth function, so it's here in the shape class. So you see that, so this is a shape class and there is a setWidth function over here. Okay, so to calculate, before we calculate the area, so we set the width and height, and that is stored in the shape class. Then in the we take that shape pointer object and we assign it to the address of rectangle. So when we now, even though shape pointer is pointing to class shape and we call area, what gets called is the rectangle area function, because at runtime the compiler, the execution code will know that you're pointing to a rectangle object actually, so it will call that particular area function. Okay, and in the same way, when we say call the same function over here, shape the area, what happens is we actually calling the triangle area function. So let's see if we can execute this. Okay, so I'll have to actually go to that project. Oh, so here is where the executable is. So let's go there. Okay, so let's call this start this application. So let's ignore the container part, but if you see the top part, rectangle class area is equal to 70, triangular class area is equal to 25. So the container is kind of a similar polymorphism example. So here we have a container. So basically we want to display what is there in the container. So the container, here we have two types of container. One is the list, so you see the list object, and another type is a vector. So here is a vector. So we are creating the container in the derived class, and we are displaying the container in the derived class. But if we want to display any container, whether it is list or vector, so we have implemented one method in the base class. So depending on which container you pass, it will execute. So here we use it. So since we do not know whether a list is passed or whether a vector is passed, we are kind of saying the container is a pointer, right? So it's again like shape pointer. We have a container pointer, so it will either point to list or either it will point to a vector. So if you see the main function, initially we call the display container of the derived class, but when we say display any container, we are actually passing the object of type container vector, the derived class vector, and in this case we are passing the derived class list object. So whether list is passed or vector is passed, it still works, and it's implemented in the base class. So if you want to see it again, we can go there, right? Okay, so here you see list contains all these elements, container contains all these elements, so it is a list, and here we are calling the any container, that base, so it returns the same values. And same way, this is when say vector contains, we are actually calling the display container function in the derived class, but we are using the same vector and passing it to the base class, and using a common function to display the elements of the vector. So it's the same elements which is there in the vector as well as list. Okay, so that's how this project works. Thank you.